At year 0, they were 48, okay, 48,000. Year 1, they went up to 59,000. Year 2, they increased to 66,000. Year 3, 75,000. Year 4, 80,000. Year 5, 90,000. Increasing every year. Are they increasing by exactly the same amount every year? No, no. And you'll notice when we plot this information on a graph, do we get a totally straight line? No. So what we want to do is we want to come up with something which is called a line of best fit. Now, when you draw a line of best fit, you want to try to have as many points above the line as you have below the line. So you can pick any 2 points. It does not matter which 2 points you use. As we get further into this, we're going to talk about regression lines, and we're going to be talking about how important it is that these points be close to that particular regression line. But we'll get into that in a little bit later. And what we'll do is we'll be able to use 2 or 3 different sets of points, be able to compare those from a regression perspective to tell which one of those lines is the actual best fit for what's going on here. But I don't want to get a little bit too far ahead of myself. Right now, we just need to pick 2 points. I'm going to go ahead and use the point 266 and 480. Okay, 266 and 480 is the one. No, we use 590. We use 266 and 590. So I've got 266, which is here, 590, which is there. Let me get back down to 48. Get 266. There we go. 590, which is here. There we go. When I do, I get a line that looks like that. So there we go. So I use 266 and 590 for my 2 points. And you notice I've got a couple points that are above that line. I got a couple points that are below that line. So we're in pretty good shape there. Now what we want to do is we want to find out what is the mathematical model or the equation of the line that is going to go ahead and show what's happening with this particular furniture store. Well, I've got 2 points. I've got the point 266. I've got the point 590. So the first thing I'm going to do is I'm going to go and find the slope of that line. The slope of this line is going to be equal to y2 minus y1 over x2 minus x1. Well, 90 minus 66 is going to give me 24. 5 minus 2 is going to give me 3. And I found out that the slope of that line is going to be equal to 8. Now, in all of the financial problems that we do, when you're dealing with slope, it's extremely important because your slope is going to be your average rate of change. Okay, your average rate of change. In this case, that 8 represents you have a change of approximately $8,000 every year in sales. Okay, in sales. Now, we're pretty good so far, but they want the equation, the mathematical model. So I'm going to take this slope and either one of these points, I'm going to use 590 to come up with the equation for the line. So I've got y minus 90 equals 8 times x minus 5. So I've got y minus 90 is equal to 8x minus 40. So y is going to be equal to 8x plus 50. There is a linear model which is going to be modeling the data that we have from this particular furniture store. And what we can do with that then is we can go ahead and make predictions. For example, let's say I want to have a pretty close prediction to what the sales of this particular furniture store is going to be in year 7. Well, no problem. I'd have y minus, or y equals 8 times 7 plus 50. So I would have 56 plus 50, which would be 106. Okay, just be 106. I made it 106,000. That's what it would be approximately in year 7. I could find out what's going on in year 10. Now, you can't go out too far because there's a lot of things that can happen from an economic perspective, but this can give you a pretty good idea of being able to make predictions. And that's one of the things that linear functions are used for in a business perspective, is to come up with a mathematical model that's modeling the data that you have so that you can use that mathematical model then to make future predictions. Okay?